Ladies and gentlemen, it is with pleasure that I introduce you to today's presenter, Dr. Joe Hummel. He's a software architect, author, and professor at Lake Forest College. Joe, without further ado, I'll turn it over to you. Thank you.
Excellent. Thank you, Mariam. And while Mariam was talking, we're aware that we've been having audio problems the last few weeks. So, Mariam, if you could post the dial-in phone number to everybody.
Absolutely.
Sounds good. Thanks, Mariam. And meanwhile, I'll just sort of get us started, and people will have time while they dial in. So cool. Just answering a couple questions in the log. Okay, there's Mariam. So Mariam has just posted the number. I'm going to close that. Okay, so welcome everybody. This is Joe Hummel. I'll be leading today's webcast, and we're going to be talking about database programming in .NET. So this is a series, a 15-part series. We are on week or session number 7, week 7. Next Tuesday we will have a break and then start up again 2 weeks from now. The reason that's important is that I want to make sure everyone has the right perspective today, because database programming obviously is a very important subject, and it's something that I cannot do in 1 hour and do it properly. So it's really actually going to take me to do this right. It's going to take 4 weeks. So let me talk more about that. But as you can see, it's 15 parts, and the next 4 there are listed, 7, 8, 9, 10. That'll take us through most of May. But it really will take a number of weeks to do this right. Today's session will focus on database programming. And the idea is you're a developer, you know what a database is, you know what SQL is, and the idea is how do I do this in .NET? And the idea of today is to lay this all out. And then what we'll do is sort of shape it over the coming weeks and use it properly. But today is kind of like just let's talk about how it's done, and then later we'll come back and hit this and talk about doing this, good design, good things like that. So today's objectives, obviously the majority of today's applications revolve around databases. ADO.NET is the technology within .NET. So ADO stands for Active Data Objects. And this was the technology that we had in earlier, for example, VB6. We use ADO to hit databases, and so this is the .NET flavor of that. They kept the name, so Active Data Objects ADO, but you'll find, and there's some similarities. But what you'll find, at least my overall impression, is that ADO in its previous state was very large and lots of different ways to do things. They've basically taken that and reduced the number of ways to do things, so that sort of the idea is to focus you into one of, let's say, 4 ways. And so it's not so confusing as to which is the right approach. There's 4 right ways. You just pick the right one for your situation. But if you know ADO, you'll be very comfortable in ADO.NET. There's differences, but overall the sort of philosophy is the same. Open, do your work, and close. ADO.NET represents the ongoing evolution. Microsoft has sort of gone, we had ODBC, we had OLADB, and now you can sort of think of as this is the next evolution in the step of database technology and strategy from Microsoft. Idea today is to lay out the way you do this. What is ADO.NET? How is it architected? How do you read from a database? How do you write from a database? There's connected ways to do this. There's a disconnected way, like we used to have disconnected record sets. What's the equivalent here? Basically, just lay out the techniques for how you do this. Okay, so hopefully if you're having problems with the audio, you can dial in now with the phone. The number there should be in your question and answer queue, the 1-800 number. But okay, so again, let me be clear on today's perspective because it's important, I think. What I'm going to do today is there's lots of tools out here that can do these things, right? There's wizards, and if that's fine for you, then go for it. My goal today is to explain how the code works. So I'm not going to use any wizards today because I want you to see the code and understand what your choices are. And then over the coming weeks, we'll talk about what things fit where, what's the right approach in different situations. But today is we're going to write code. I'm not going to use any tools. I'll mention a couple at the end. I'm also going to just sort of, again, I'm just going to the philosophy today is just get this all out so we can talk about it in the coming weeks. So I'm not going to do a lot of elegant design. In fact, I'm going to do some really ugly stuff. I'm just going to hack today. So today's kind of a fun day. I just get to hack. All code will be in the GUI, which of course is bad. There should be a data tier. That's going to be coming in next week and beyond. All code will be explicit SQL. I'm not going to work with stored procedures today because to me that's kind of an orthogonal issue. Whether it's SQL as a string or whether it's a stored procedure, we can sort of put that off to the side and talk about that later. So today, all explicit SQL. No stored procedures. We'll again talk about that later. The last thing that's going to happen today is I'm going to work with Access and I'm going to work with SQL Server, just so you can see that the same stuff works with two different databases. But I'm not going to do that in a very elegant way. I'm basically going to copy-paste the code and change it, which of course we're going to see a much better way in the coming weeks. But so the point here today is lay it out, show you how it works, and then I really hope you can come back or at least get the webcast for the next following 3 weeks. Because what we're really going to do is show you interfaces and inheritance and multi-tier design and build data tiers in a very elegant, reusable, well-designed way. But again, it's going to take me 4 weeks to do that. So today is lay it out. And we'll come back and make it elegant in the coming weeks. So that's my perspective for today. The examples we're going to do today will be very familiar. And it won't require you to have much knowledge of the database schema or anything. It's basically just a simple sales database. I'm not going to get that deep into it, but basically it has 4 tables. We have customers, and the customers place orders. So we have an orders table, and then we have order items, because a customer can buy more than one product. So there's customers, orders, and products, basically. Standard, very simple database. We're selling animals today, so flying squirrels, cats, and dogs. But basically, we're not really going to get it too deep into that. I'll pretty much just work with customer objects and customer data. But just so you know, it's a sales database. Here's the schema for the database. It basically has 4 tables. One customer can place many orders. You can have, one order has many order items, and then there can be many order items or many orders for the same product. So basically 4 tables, as we put all pretty much guess in a real sales system. This is way too simple, but it's enough for today, so we can write some code. And again, primarily we'll be working with the customers just to keep things simple. Okay. So that's the perspective for today. So we're all on the same page. Let's just talk about ADO. Let's look at it in its raw form. How do I use it to hit a database? And basically what I want to show you is that there's 4 ways to do this. And what your goal is going to be over the coming weeks is to see, okay, well, I have these 4 ways. Which is the right way for my situation? But today is just lay out the 4 ways. And what I want to do is just jump right into an example. So let's look at one of the ways to read from a database. So let's just real quick go through an example. We'll run a demo, and let's just start looking at some code. So the example I'll do is I'm just going to have a little GUI application that will read customers from an Access database. So Access 2000, it's a nice one to use for teaching basically because I don't have to have anything. It's minimal install, right? Access file. Very good for teaching. It's just to use Access. And then what we'll see is the same philosophy works whether it's SQL Server or Oracle. Won't really matter. But for now, I'll work with Access. What my application will do is I'm going to use a server-side cursor. So this will be one of the options that we can sort of do it this way or a different way, connected or disconnected. So what I'm going to do is read in a connected fashion, which means the application will connect to the server and then request the records one by one. And I will maintain that connection to the server while I am retrieving or requesting the records. So there's a server-side cursor, and the application, the client, is maintaining this connection to the server. So this is one of the 4 ways to hit a database. And what you're going to see, the steps here at the bottom, we'll just go through these in 3 slides. So I'll go through the code quickly, and then we'll go run the demo. Basically, you open a connection. You execute USQL and retrieve the records, because in this case we're reading. So basically you open, you do your job, and you close it when you're done. That's the standard way and you'll see that pattern repeated over and over and over again today. So open, do it, close. Okay, so step 1. Step 1 is to open a connection to your database. And the way this works is there's basically every time you want to do something, you interact with an object. So it's an object-oriented programming model. So what you have to do to open a connection is you basically connect or create a connection object. You create that object and you say object.open. Now, so we're going to be working with access for the time being. So you'll notice up here at the top, what I have is a using declaration. And what I'm going to do is basically import the namespace that has the classes that I want. So an access database is an OLADB database, and that's the technology, the set of classes that I will use to open that database. So I'm just going to use an alias called MSA, Microsoft Access, and that alias will basically point to the set of classes that I'm using here, which are the OLADB classes for opening a OLADB database like Access. So really, it's like opening a file. You just got to get the name of the file or the path to the file correct, and then you can just basically open a connection to that database. And so what we do up here, the key thing, and I'll say more about this in a little bit, is getting this connection string right. So if we look at this connection string carefully, I'm using string.format. So I'm going to build strings efficiently today, which means I'm not going to use concatenation. The best way to build strings is string.format, especially when you have lots of pieces that have to get put together. And it's also more readable. So basically, to open an access, I need a provider. You know, what is the driver that I need? And it's going to be OLADB driver. And where's the data source? And basically, that's the full path to where the file resides. So you'll see below the string, here's the provider that we use, Jet OLADB 4.0. And then you'll see that I'm getting the base directory for my application. Basically, that's where the executable is. And then the name of the actual database file, the access file. So I'm slamming all that together into what's called a connection string. And you have to be very careful how you format those. But basically, you specify the connection string, and then you basically create the connection object. So you create this new OLADB connection object. You pass the connection string to the constructor. You get back a connection object, and you say object.open. If you don't get an exception, then the database, the state of the database is now opened, and you now have a live connection to that database. So assuming this code works, at the end of this slide, at the bottom of the code, what you basically have now is a connection object that is pointing at your database. And now this is how this is the first step into hitting that database, is going through that connection object. So step one is, I want to do database, I got to open a connection to it. And as you'll see, it'll be the same approach every time. The only thing different is the connection string. Okay, here's the busy slide, step two. Now that we've opened the connection, what we want to do now is basically start retrieving records. And what you're going to do is basically send some SQL to the database, which will get executed, and then you start retrieving records. So you can really look at this slide in two pieces. The top part of the slide is basically sending the SQL over to the server for execution. So what I do is, you'll see that the SQL equals, it's just a standard SQL query, select star from, and just have it sorted by customer name. And then what I do is create a command object. So now I have a command object, and then I'll tell that command object to execute the SQL. So the command object is created and is passed the SQL to execute and which database, the connection. So you tell it which database, it'll go through that connection to it. You give it the SQL, and then when you're ready, you say basically, hey, command object, execute. And what you say, and then that basically executes the SQL. And once you've done that, assuming all that succeeds, you now can start requesting the records. And that takes us to the second part of the slide. So let me erase that first part. So the first part of the slide is basically get your SQL set up and execute it. And then the bottom half of the slide is, if the top part succeeds, what you now start doing is reading records. And the way you want to think about this conceptually, how it really works is they probably batch up the records and send them. But just think of it conceptually. You get the records one by one from the server. So what you say is data reader.read. You retrieve or request a record, and then if that returns true, that means a record was available, and that record is then brought down to the client. So you basically get one record brought to the client, and then what you do is process that record, loop around, and read the next one. So this is a server-side cursor. You maintain a connection to the database, and you read the records one by one from the server. Basically, read will return false, and the loop will stop when there's no more records. So you basically sit here and loop, processing the records one by one as they come to you. And what you do inside the loop is basically pull the data out of the record. And so what you do is think of that record as, I mean, a record is really just, it's one row of the table. And if you think of that row of the table, let me draw on the record, it's just basically a row with some data in it, based on the fields. But if you look at that, that's a one-dimensional array. So think of that record as a one-dimensional array. So if you look at the syntax here, you'll notice how you retrieve things is using an array-like syntax. That's the easiest way to do it. The difference is, in fact, you can use integers. You could say, give me fields 0, 1, and 2, but then you have to know the layout of the table. The easier way is just basically say, I want the first name, I want the last name, I want the account balance. And what it does is basically you're indexing what looks like an array, but it's a record of a table. And you can either index it by integer or by string, and the string is the field name. So once you retrieve or read a record, what you then do is reach in there by field name or integer index, pull out the data, and what I'm doing here is creating a customer to hold that data, and then I'm just adding it to some data structure. And then basically we'll just play around with the data structure, display it, search it, whatever, So the step 2 is we've opened the connection, now we execute our SQL and start retrieving records. And of course, now once we've retrieved all the records, we've converted them basically into objects. And then step 3 is just to, okay, once we have the collection of bank customer objects, we don't need the database connection anymore. So the last step is close the connection. You close the database reader, the object that we were using to read, and then if you're done with the database, you close that as well. So close the reader, close the connection, and then I do a little message box here to pop up the state, and then what you see is the state of the connection is now closed. So that connection's been broken. Okay, so let's do a quick little demo. I'm going to pop over and let's just run this real fast, and then we can talk about it. And and modify a little bit. Okay, so bank customer Microsoft Access. So I'm going to run the Access version of this, and you'll see the same application a few different times as we play around. Okay, so I'm actually, just for time's sake, I'm not going to write a lot of code today. The code's already basically in most of these applications. So I'll just point out the code. But the code is basically cut and pasted from the slide. So I'll bring up the form here. And again, there's no elegant design here, no business tier, no data tier. We'll fix that next week. So here's my form. It's just a single tier application. I double click on the form background, and here's the load event. And basically what you'll see is the exact code that was we were just talking about. So the first piece of the thing is to open the connection, and then what you'll see is we'll message box, and you'll see the connection is open. Then what will happen is step 2, which is we will loop around reading all the records and creating bank customer objects. That will be step 2. Then after step 2, we will close things up, and then you'll see a message box that says, okay, the state of the database is now closed. Once things are closed up, what we'll do is basically bind that data structure to a list box, and then we'll see the customers on the screen. So let me just go ahead and run that, and if the world is in proper order, what we should first see is we'll see a message box that says open. So the load event has triggered, and the database has been opened. We're now retrieving the records. We've done with that. We've converted them into objects. Now we've closed the database. The main form comes up, and we see the objects in the data structure displayed in the list box. So very exciting. So, but that's a quick overview. What you're going to see is that same pattern over and over again: open, do something, close, or open, do a bunch of things, and close. But it's a very, that's basically the idea is, and there's basically, once you open it, there's just 4 different ways of doing what you want to do. Am I reading? Am I writing? Am I connected? Am I disconnected? So, that's basically going to be our 4 things. Let me just shoot. So here's the source code. If I go in bin debug, there's the database. So there's the executable that we're running, and there's the database, the Access database. So I'm assuming it lives in the same directory as the executable, the database. So again, Access very easy to work with. Okay, that's basically the first set of the lecture. Let's talk about a couple of things while we're here. Okay, of course, the right way to do this, we've talked about defensive programming, in particular exception handling, critical with databases because there's so many things that can go wrong. Of course, what you want to be doing is try catch here. But let me actually show you what you want to do. The best practice is, and there's a slide on this, so we'll come back and look at this slide. Exception EX. Because the issue is you want to make sure the database gets closed. So the right way to do this code is to use try catch finally. I mentioned this before as what you want to do is make sure that objects get disposed of. Which means like files, you want to make sure the files get closed. Databases, you want to make sure that connection is closed, whether you get an exception or not. So the right way to program this stuff is with try catch finally. And then in the finally block, you make sure you close things up. And that way, if exception or not, things are cleaned up before you start going off and doing exception handling. So this makes sure, because connections are very expensive resources, and so you want to make sure those things are returned back to the connection pool or just not sort of floating around waiting to be garbage collected. So, and the right way to do this is because, the easiest way actually is you want to do your closing in a try catch block, because you don't know at what point it failed. So did it fail during the open? So closing it may fail. So you can have you can nest the try catch stuff, right? So the right way to do the closing is to nest that in a try catch in case the close fails, because you may be trying to close something that's not open, and so that's the right way to write that. To make this compile, we got to move these variable declarations up into the top, and then initialize them to null. So we need the reader object up there, and we need the connection object up there, because it has to be in the right scope so the finally block can get to it. So try catch finally is the right way to do this. So of course it's not throwing an exception here, so there's no real issue here with needing exception handling at this moment, but in general that's the right way to do it. Okay. Oh, one other thing. So let's see, try catch, yeah, I got that right. Just so you know, when I catch the exception, I'm throwing it because I have a generic exception handler for my WinForms app. So last week we talked about how to hook up a generic exception handler. So I'm assuming there's an exception handler to catch everything from my entire application. It catches it and logs it to a file. So we did that last week. So really, when I get an exception, I just throw it and let the generic handler handle it. I'm not willing right now today to deal with it any better than that. So I have a generic exception handler that's dealing with that. The last thing you want to be clear on with the way things will work today, and when you use ADO.NET, and this is something that you just have to, you'd recognize it once you thought about it for a second, but let me just state the obvious, just in case. The way we're going to be executing SQL today dynamically, meaning we're going to build SQL queries and send them, and they'll be executed on the fly. No stored procedures or anything. So all the SQL is going to be interpreted at runtime by the database engine. Now, what you want to just be clear on is that from the perspective of Visual Studio and C# or Visual Basic, they have no idea what we're doing. From the perspective of C# and VB and Visual Studio, this is just a string with a bunch of letters in it. The compilers, unfortunately, right now are not going to be able to help us make sure the SQL is correct. So in other words, I can type whatever I want here, right? Now that is not valid SQL. Okay, that's absolutely looks like junk to me. But I can certainly go ahead and save that code, and I can go build this, and Visual Studio will happily compile this code. And C# compiler happily compiles this code. Because C# it's just a string. You're not going to know it's wrong until you run it. So now when I go run the application, this thing's going to, okay, it opened, but when we try to execute the SQL, it's going to blow up. Halting due to error. So here's my generic exception handler kicking in. The select statement includes a reserved word or argument that is misspelled. So basically the SQL is bad. And so the application halts because that's what I do on an exception. So just be aware that the tools, if at this level, which is I'm just passing strings around, are not going to help you. What a lot of people do is they have Query Analyzer open. They work on they build the queries in some kind of tool, and then copy and paste the SQL in here, and then run it. But just be prepared that if your SQL is incorrect, you're not going to know till runtime. It won't blow up until you actually send it to the database engine and try to execute it. So what's happening is it's blowing up right here. When you try to execute and get a reader object back, that's when that SQL is blowing up. Okay, let's go back to the slides. Okay, so there we go. So that's basically the broad overview. You're going to see that pattern repeated over and over and over again. And here's the slide about defensive programming. You want to use try, catch, finally here. In C#, you could also do the using statement. So you could have a nested using, one for the connection and one for the reader. So you could have two using statements that are nested inside each other. So you can use that quote using statement. I'm not doing it here because I like to try catch finally so that if you're in Visual Basic or some other language, the same technique works. So I tend to avoid the using statement because I want to do things that work in other languages. So try catch finally is, I think, just a more general approach in the sense of it's language portable. Okay, so I'm going to pause here for a second, take a couple questions, and then we'll move forward. Yeah, okay, so John had a question about the connection string. I'm going to give you some hints on how to build the connection string. Visual Studio will only give you help in building the connection string if you use one of the tools, like if you drop a connection object from the toolbox onto the, and then start clicking through the dialogues. It'll build the connection string for you if you use a toolbox connection object. But I'm going to point you to some websites that will help you build connection strings. Why is this connection a server-side cursor? It's basically it's the way we're using it, which is it's a server-side cursor because of the way we execute the underlying SQL. So connection strings just maintain or just consider opening the connection. The kind of cursor, server-side, client-side, is going to be driven by the technique we used. So it was because I used a command.executeReader method is what, it's due to the method call that we make is why it's a server-side cursor. Yeah, I'm going to avoid, I don't want to get into multi-threading, so hit me up at the end. I'm not going to talk about performance until we get to the end. But basically today, the goal today is just I want to show you the 4 ways, and then we'll sum it up with trade-offs at the end. Ah, thank you. Yeah, Chris. I always forget all these tricks. So Chris is going to remind me of a good trick, and let me post that to all. Post to all. Basically, one way to get so if you want to build a connection string, use a wizard of some kind. So Chris just had a good idea. I always forget. Create a UDL file. Put it on your desktop, right-click, brings up the wizard. You can click through it, and then it will save it to the file when you're done. So thanks, Chris. Okay, I'll take one more question. Pradeep had a question, server-side. What's the difference between a server-side cursor and a client-side? Basically, it's where the work is being done. If the cursor, basically, if the records are on the server, then the client has to ask the server for the records. So the server is participating in the processing of the data in a long-term sense. So the client is, in some sense, asking the server, give me a record, give me a record, give me a record, give me a record. So the server is involved in the client in the client's execution for a longer period of time. Which, in other words, it requires server-side cycles to get through the records that are being retrieved. A client-side cursor basically means you go to the server, get all the records, bring them all back in one shot, and then you work on them on the client without bothering the server. So all the work is being done on the client. So think of server-side cursor meaning the server is doing most of the work. The client-side cycle means the client side means really the client side is processing all the records, and the server is basically out of the loop. Okay, cool. So let's look at the architecture a little bit. Thanks for the questions. So that was our broad example. Let's look at the architecture, and we'll start talking about the 4 basic ways of hitting a database. Okay, like most of these approaches, ADO.NET is based, what you really want to do is separate ourselves from the actual details of the database, right? We don't want to have to write the code differently when I move from Access to SQL Server to Oracle. Or if I work with different databases, which a lot of us do, I don't want to have to learn new techniques. So the idea is just encapsulation. We, as the programmer, we live up here. So we basically interact with ADO.NET. We interact with these objects. And then the job of the vendors, or Microsoft, is to provide drivers, or what we call providers, that handle the database-specific details. So basically, we just work with these objects, and then as long as you have the appropriate provider, you just sort of install that thing, and you can talk to the database. And so what I'm using is the OLADB provider, which was given to, which comes with .NET. So it allows me to talk to any OLADB database, such as Access. So, but the beauty of this is we live at the top here, and it really, for the most part, for many things, we can sort of ignore what kind of database it is at the bottom. Just like when you print, you don't care what kind of printer. You just install the printer driver and you print, and the printer driver takes care of the details. Same idea here. So .NET ships with various data providers. Basically, at this point, I believe there are 4. There's SQL Server and Oracle. So Microsoft basically ships you 4 drivers or providers, SQL Server and Oracle. And these are native providers, which means this is .NET code. Excuse me, I had to sneeze there, sorry. So you have native providers, which are basically .NET code, efficiently written, optimized code for SQL Server and Oracle. And then you basically have compatibility software that works, but it's not been optimized for .NET. And this gets us to the older technologies, OLADB and ODBC. So when you want to use native providers. They're just going to be more efficient because it's .NET specific. But the older stuff works, as we just saw, which was Access. Of course, companies are providing drivers as well. So you can use any database either through, like if a database has ODBC, you can get to it today. Or if that vendor has a driver for .NET, you just basically go look and see if they have a native provider. So of course, Oracle has a native provider that they have written as well. So Microsoft wrote one, and Oracle themselves have a provider for .NET. If you want to use MySQL, there are providers for MySQL that are native to .NET, DB2, so on and so forth. So really all you need is a provider. Either use one of the ones that Microsoft provides or get one from the vendor themselves. You plug that in and install it, and then you can start writing ADO.NET code. Now the object model, which I want to demonstrate here in a second, is vendor neutral. So the idea is we live at the top as programmers, and we're just going to use these objects. We're going to create them, feed them SQL, and execute it. And in that sense, it's vendor neutral. Everybody executes SQL. As long as you write standard SQL and send it to the engine and it understands it, it'll execute. So you can, for a large bodies of your code, you can avoid the fact that down below there are different databases. So they definitely take a vendor-neutral approach, and then if you want, you also have the ability to use the capabilities of that particular database provider if you want. But you can live at the top level and just pretend that all the databases are basically the same. The way it's going to work is it's the same programming model. You open an object, you execute some SQL, and you close it. So open, do it, close. What you'll see is there's different connection strings based on that's vendor specific. And database specific, so different connection strings. And then what you'll see is there will be different classes. And there's different classes so that if you want, you can actually get into specific details of how that database might work. So for example, for SQL Server, we will be using these classes, which is system.data.sql client. So there's another namespace where SQL Server classes are, and we will use those objects when we talk to SQL Server. And then for Oracle, there's another set of classes that are Oracle specific, and then there's ODBC classes, there's MySQL classes, there's DB2 classes. So today what I'll do is just very copy paste and change the code. Later in the next coming weeks we'll see a more elegant way to do this. But today I'll just go use the classes that are specific to the database, and that's what you have to change. You just change over what classes you do. So it's the same programming model, meaning the objects are programmed the same way. But instead of creating an OLADB object, I have to create an SQL client object. they program the same way. I just have to instantiate different objects. So at first it looks kind of silly, but you'll see in the next couple of weeks that there's an elegant design approach to this underneath that you'll appreciate in the coming weeks. Okay, so let me jump into demo 2 here. All I'm going to do is run the same demo, but I'm just going to use SQL Server instead of Access. So let's see, SQL Server is running. So if you look in the bottom right of the screen, you'll see that SQL Server is running. I'm going to bring up query. So a nice way to work. One of the great things about SQL Server or any server databases that at least with the tool set, the appropriate tool set. The way I like to work with SQL Server is I have basically an SQL file, a text file with the SQL commands to create the database. So whenever I want to work with with these demos, I basically just open up Query Analyzer. So I bring up Query Analyzer, and then basically I can just rebuild my database. I drag my SQL file over into Query Analyzer, I execute it, and it goes in, talks to SQL Server, and builds my database for my demo, and repopulates it with data. You probably all do this, but I like that. It's great for demoing things. So now I have my database set up, and these files will be up on the website, so you can work with these demos and things, and build. And this file here will build you the database you need with SQL. So let's go down into the demo, the SQL Server one, bank customer app, and then let's look at the same application. Let me just rewrite it for SQL Server. So things are firing up here. Okay, so let's bring the form up. Close those windows. Okay, so the code again is all in the load event. So basically what I'm going to do is program this for SQL Server. And I'm going to do this the naive way, which is, hey, different database, different classes I got to use. So I'm going to go up to the top, and first thing I'm going to do is change the set of classes I'm using. So I'm going to change my import or my using statement to be system.data.sql client. So I'm going to import a different set of a different namespace. So now it'll be SQL dot, and that will be the SQL Server classes. So now I go back to my code, and this is really tedious, but this is, at least when you do things in a naive way, what you'll see is it's the same objects, but they have different names. So now I got to go through and change all these. That was a data reader. So let me just change all the objects first, and then I'll go back and fix the connection string. So I'm just going to go through. This is really this is just brainless. Just go through and change all the objects to SQL Server objects. SQL, that was a command object, right? Let's try to build that and see if I missed anything. Oh, missed one. Ah, okay, there's one I missed. Oh, what's that doing there? Oh, okay, sorry. I may have to rewrite more code. You know what? Let's just comment that out for a second. That's for the next demo. I forgot about that code being there. Oops. Okay. All right. So first thing was I basically went through the load event and changed things over to use now the SQL objects. So, and again, same programming model, which means I don't change anything else. It's just different objects, but they work the same way. Now, the other thing you got to change is the connection string. And this, I'm going to point you to a website that basically will, help you figure out how to build these things. But what you need to do with a server database is tell it where the server is, and that's just going to be localhost. And then what database is it, and that's just going to be sales. And then the third parameter is how do you want to log into this thing? So I'm going to use integrated security with Windows, INTEGRAT, integrated. Okay, so let's see if I have that right. And again, it'll compile fine. We're just going to know when we run it. But I'm just checking my notes to make sure I have this right. So server equals localhost, database equals 1, which is sales, option, and parameter 2 is integrated security. So this should run fine. SQL Server is running. The database is created. It should fire up. So we should see an open So we've opened the connection to the SQL Server. We're now reading the record. We closed the connection, and now we have the data to SQL Server. So now we're working with SQL Server and no longer Microsoft Access. But the really only proof of that is this connection string. So you gotta hit that, and that sort of demonstrates, okay, we're going to a different target now, which is SQL Server. Okay, that's really all I wanted to show you was same programming model, but a few details change, connection strings and the classes that you use. I think I'm going to close that. Okay, and go back to the slides. So that's basically the architecture. That's what we were talking about, is the architecture here of .NET, of ADO.NET, is basically there's different classes for the different technologies. And you just basically use the set of classes that's appropriate for you. You got to figure out what the connection string is, but the same programming model in each case. Now, help with connection strings, Chris. I should have put your hint here with the UDL files. There's tons of practical ways to create those connection strings. So I'll make that note next time, Chris. Thanks. But connection strings obviously are vendor specific, and unfortunately, surprisingly, not well documented. So these are two websites that I use to figure out, okay, SQL Server, Oracle, show me some things of how these are built. So there's some websites to point you in the right direction, or use the wizards and see what the wizards generate. And then here's the executive summary slide. Basically, here are my 4 ways of hitting the database. And so the task that you're trying to perform is on the left, and then the way you do it is over on the right. And if you're familiar with ADO and the way we used to do it, for example, from VB6, there was many, many, many more ways to do things. And what Microsoft realized was, you know what, there's really just a few right ways to do it. And so they've sort of narrowed it down to these 4 ways. And you can sort of various ways to slice these up, but basically what I'm going to do is go through these 4 techniques quickly, and you'll see that we'll probably go past the hour, which I typically do. But I'll just basically demonstrate most of these or all of these. But you'll see that the first 3 of these are connected, which means you are connected to the database and you are working with the database to do things. And which is one major way to do it. The other way is to basically disconnect, which is like sort of get the data and disconnect, which basically means you unhook from the database, so you're no longer using the database server or server cycles. So you bring all the data to the client in one shot, and then you basically can manipulate it locally in a disconnected state. And then if you want, you can reconnect later and upload all the changes, all the additions, all the deletions, all the modifications. So that's the disconnected option. In VB6, we had disconnected record sets with ADO. So disconnected record sets have basically become data sets. So that's kind of like a big way to change, to group these, is do I want to maintain connectedness to the database, or do I want to work in a disconnected scenario? And there's pros and cons, which we'll get into at the end. But the summary is, if you disconnect, it's just, if you try to update the database later, it could be days later potentially, and then you have to deal with all the conflicts that happen between the time you suck the data out and the time you put it back, because you can't run a transaction across a disconnected state. It's just too long. So that's kind of the big grouping here, connected versus disconnected. And then really it breaks down to what are you doing. If you're connecting to the database and staying connected, if you want to read one thing, there's an optimized form called execute scalar. What we were doing is read-only access of multiple values and records, and that's execute reader. And if you want to modify the database, you basically send it SQL and you say execute non-query, meaning I'm not getting data back, I'm just making a delete, update, or insert. So, one value, reading lots of values, making a modification. There's 3 different methods. You open, execute the methods, and then you close it when you're done. If you're going to work in a disconnected scenario, you basically are going to create data structures called data sets, and you're going to work with them offline. And then if you need to, you reconnect to the database whenever you want, and then write the changes back or update the database based on how the data structure has changed, the data set. So those are your 4 ways. Those are the things you choose from. And again, we'll talk more about the situations later today and then in the next coming weeks. The other big decision I'd say is, are you going to go with stored procedures or stay with SQL? And it seems there's pros and cons again there. Who do you want writing the SQL? Do you want to have just the database administrator folks writing that code, so then you sort of fix the SQL and make sure it's correct and according to the DBA standards and it's in stored procedures and no one else gets to write it? Or do you want a more flexible system where you can send SQL from the application directly in? Or maybe you do a combination of both. Who knows? That's I think a very big decision as well that you have to make, but we're not going to get into that today. Okay, you know what? I'm going to bypass the queue here for a second. I'm going to keep moving forward. Let's do a few more examples or a few more ideas, techniques of let's look at these 4 ways of doing things, and then I'll take some more questions, and then we'll finish up with how to modify. So let's focus first on reading from a database. There's basically 3 ways. In that chart of the 4 ways, 3 of them were based on reading. Read one value, read a bunch of values, or disconnect and get me all the values and then disconnect the database. So let's look at the 3 different ways of doing it, basically one of which we've already done. So let me just pop up a quick slide. There's a method called execute scalar. So it's the same idea again. You open, execute some SQL. The idea here is what you're retrieving is one value from the database. So database command.execute scalar. So what you're doing is your SQL is written to return a single value, like get me the customer's balance, or get me their zip code, or get me their phone number, or their email address. And so it's optimized internally, if possible, to do because you can optimize your locking strategy, for example, based if you're just going after one thing. So this is solely designed for getting one thing back. Okay, if this SQL returns a table, it takes the first value in the first field. That's what this returns, the first field of the first record in the answer. So, but again, open, execute some SQL, and then what you say is command.execute scalar. You get one value back, which is an object, and you convert it to what you want or what you're expecting. In this case, I'm getting the balance, so I can system.convert that to decimal because I'm expecting a monetary value to come back from that query. Notice here, we're going to sort of introduce you to this slowly. Again, this is the more realistic scenario, which is where you're building SQL on the fly. So if you look up there at the sort of mid-right there, you'll notice I'm building an SQL where I have to embed the customer's ID to search for. So I have a select account balance from customers where CID equals and then argument 0, which turns into that CID parameter. Whatever the user types in, I get that customer ID, I embed it into this SQL. I build it dynamically, and I'm going to send that SQL over to the server, the database engine in the server. So you're more likely going to be building these SQL commands on the fly by embedding the parameters for the searches and things into the query. The right way to do that is string.format. It builds these strings efficiently. Okay, so that's execute scalar, one value. We've talked about execute reader, so I'm not going to go through this again in any detail, but basically execute reader is a forward-only, read-only cursor. So I guess in the VB6 and the ADO days, we call this the fire hose mode. The records are shot to you from the server to the client one after another. So you can only go through this once. It's forward-only, and it is read-only. You cannot modify the records in this format. It is forward-only, read-only. That's it. That's its intended purpose. And basically, as you see at the bottom here, this is the way to view this. What the client does is talk to the reader object and request records. And those records are being sent to you from the server. So it's the cursor's on the server, and the client just makes requests, and the server feeds them over to the client as requested. So you're maintaining this connection to the server. Forward only, read only. So we saw that one. No need to dally there. So those are options 1 and 2. Read one value, read a bunch of values. The last way to do things is this notion of data sets. And this is the sort of flip side in the sense of this is the disconnected option. So let's talk a little bit about data sets, and then I'll show you an example. We'll bounce in and do another demo. So really, the way to think about a data set is it's really just a data structure. We talked about briefly array lists and hash tables. They're collection classes. The data set is really just another collection class. It's just a data. It's just an object that holds data. The deal is it's specifically suited for databases because it's designed specifically sort of for two-dimensional arrays or tables, rows and columns of data. So it's well suited for database data. So that's why it's primarily used. You can use it just as a general data structure. It's primarily used with databases because it's designed for rectangular data. The idea of a data set is it's easy to fill it and pass it around, hook it into GUI controls, data bind it. It's very convenient for parameter passing. So this is why it's very useful in applications that multi-tier that are distributed applications that use remoting or something, and they're going from one physical machine to another. In these basically distributed scenarios, what a data set is very convenient because you can basically fill the data set and just move that collection across the network over to the client side and work with it. And then in that sense, what you do is these are your disconnected objects. What you do is break the connection to the database and just pass this object around, and it basically will actually work like a little database. So data sets are really designed for the disconnected scenario. You're going to fill this thing with data, and then you're going to break the connection to the database and just pass this guy around. And then maybe you'll reconnect it later, or maybe you just use it in a read-only format just to hold the data and pass it around. So in some sense, this is a way to build a business tier, is you don't really have to have business objects. You could just have data sets. So this is one way to build a business tier, is you just create a data set and pass that around. So instead of having individual customer objects, you basically have a customer's data set, and all the data just lives in there, and you pass this one giant thing around. And that's another way to build a business tier. So things we'll get into next week. But basically the way this will work is you'll read from a database. So when you do that, you'll have to open a connection object, and then you'll basically will specify a command for what to retrieve, what data to retrieve. And then there's a data object or data adapter object you use, and basically what you do is you tell the object to fill the collection. So the data adapter takes the data and fills the data structure. Once that's done and filled, you break the connection database and you work with the data set, and you forget about the database. You just work with the data structure. So that's the idea behind it. And again, it's really meant for the disconnected situation, when you want to disconnect and pass these bad boys around. So I've already said that. Why use a data set? Its motivation in life is disconnected. You fill it by the server, you process it on the client, and then basically you're using client-side cycles instead of server-side cycles. And then if you want, you can reconnect it and write the data back. So it's really for the disconnected scenario. It allows you to reduce the load on the database server. It allows you to work offline. So you can imagine a laptop where you basically suck the data down into a data set, unplug the laptop from the network, and start walking around with the data, and then basically hold all the data locally in these data set objects. So that's really the motivation for these distributed applications, I think, or just convenience of passing data around instead of having to create your own objects. Okay, so let's look at how this works. Here's the basic code, and then we'll go run a demo. The idea is, again, you open the connection, and the difference here is we're going to open the connection, do something, and immediately close it, because that's the idea. The data sits locally, and you disconnect. So in this case, there's an extra object, this data adapter. So let's look at the code a little bit, and then we'll go run the demo. So you'll see here, I have an SQL string at the top. So select star from customers. I create my command object because I need a command object to execute it. But then I also create a data adapter. And basically the data adapter is just basically I have this data structure that needs to be filled. I don't want to fill it myself. I need an object that understands databases and understands the data structure and just fills it for me. So the data adapter basically takes data in from one end and pumps it out into some other output source. And in this case, we're going to have it fill a data set for us. So I create this data adapter object, and then I basically create a data set. I create an empty data structure, and then I basically have all my objects in place. I have the connection open, a command to execute the SQL. I have the data adapter that'll take all the records, read them all from the server, and then write them all to my data structure. And now it's just a matter of executing this stuff. So now the last three lines are open the connection, fill the data set, and notice I say adapter.fill. So the adapter talks to the command object talks to the connection object. All the objects communicate to get the records down and fill the data set with that data. In this case, I'm selecting all the customer records. And then I immediately close the connection, which breaks the connection to the database. And now what I basically have is a scenario at the bottom here where the connection is now broken and all the data is living in the data set. And I just work with it now locally. So that's the idea behind this. Okay, so now we've seen, let's pop into a demo and see how this works. What I would do is show you this in two different ways. So let's see, this is the data set demo. So let's go into the data set demo. Okay. Again, I'm going to show you two different ways to work with a data set. I'll work with it sort of the same way we've been doing things already, which is I'm retrieving customers and I'm going to build bank customer objects. So I'm going to sort of build bank customer objects from the data in the database. So here's the standard application we've been doing, you know, read the data, display the customers. Let's look at the load event. Now the load event here is now going to, so we're working with SQL Server. So you'll see that we're going to SQL Server here. And the difference here is I'm going to basically open the connection, fill the data set, and close it. And then once I've closed it, I just have the data locally, and I'm going to work with it. Now there's two ways we're going to work with it. The first way is think of it as a data structure. What I want to do is iterate through this data structure. So, and so basically what it has is, think of the data structure really has a table. It has the customers in there. So for each data row, each row of the table in the data set, and as you'll see, data sets can have more than one table. You can actually read the entire database. You could read all the tables into the data set. So what I'm going to do here is iterate through each row of the table. So basically for each row in the table, and by default its name is table. So there's a way to change that. You can just write in there and change the name of the table to customers. But by default it just is renamed locally to table, then table 1, 2, 3, 4, 5. So for every row in that table, what I basically want to do is now what we were doing before, which is bank customer C equals new bank customer, and then I have to pass the constructor, and I do basically the same thing we did before, which is I have a row object, or I have a record, and what I do is access that record like a one-dimensional array, and then I just sort of pull the data out from that one-dimensional array based on the field names. The last one has to be converted to decimal. Okay, closes that, closes the bank customer, and then globals.customers.add. Then I add that global customer, add that new customer to my data structure, and then I'll bind that to the list box so we'll see it. So this is one way to do it. This is kind of the old school, or I don't know, not old school, that's wrong, but it sort of maintains the existing approach of a business tier with business objects. And so I have bank customer objects, so I just get the data set and I work through it basically while I'm disconnected. So the difference is really I'm disconnected from the server. As I'm working with the database is closed, and the database can be working with someone else. So the database is closed, and I'm working now building these business objects locally without bothering the server. So now if I run this, if I got all that right, what we'll see again is the same application. So here's the data, and it's basically once I've loaded everything, it's exactly the same. I have a bunch of business objects. The difference is I just got the data differently. I opened it, sucked it into a data set, closed the connection, and then basically went through the data set manually and just built my business objects one after another. So that's one way to work with it. It's just another way to read it. But a very common way is to actually leave the data in the data set. And so I mentioned this before, is in some sense this is another way to build your business tier. You don't really have to build explicit business objects. What you can do is just think of your data set as one giant business object and just keep everything inside there. And if you work with, well, anyway, we'll talk about that in the coming weeks, but it's another way to build a business tier. And this application here is, if you do this, so let me show you this application. This is, I'm sure, very familiar to pretty much everybody. But you can just take that data set and, of course, bind it right to a data grid. And so I don't have to actually build business objects and add them to a list box and display the data when they click on the object. I can basically just fill the data set and then just bind that data set to a data grid. and then just display it. And then the data grid basically just goes through the data set and displays the data in a very obviously convenient format because it looks just like a table in the database. So that's a very common way to do it. You just have to work with the data set, the data grid, to make it be formatted properly. But if we look at the code for this version, this application uses the data grid, and basically now the application really just fills the data set, and I don't iterate through it, I just bind it. So I just DataGrid.setDataBinding. So I set the data grid to display the data set, and in particular which table. So just the table of customers. And so now it displays it for me. Boom. So very common, very slick way to do this. Assuming you just got to go through the pain of formatting these tables, these columns. But all doable. Just a little tedious programming to get this all looking very pretty. Okay, so those are your. So basically, what we've just done is the 3 techniques for reading from a database. So we have talked about, or mentioned at least, execute scalar, which is for reading one value. Execute reader is for reading many, and then data set, you fill it and just either iterate through it or bind it to something, and that's the 3rd way to read things. So those are your 3 options for reading stuff, and you just have to pick, which way you want to go. What is it that you're trying to do? Now the 2 demos I just did here basically are in the slides here. So iterating through a data set. Once you fill a data set, you can certainly iterate through it and just pull the data out because it's really just a data. It's just a collection. So just reach in there and suck the data out row by row, column by column, whatever you want. Of course, the other way we just did was one line of code, bind it to a grid, data grid, and you can just see the data visually that way. So, and then that control just binds through it. And the last thing I mentioned was with data sets, you just want to be aware that data sets are very powerful data structures, very powerful objects. So in general, a data set is unlimited in size. Like most of the collection classes, it can have any number of rows or records. It also can hold more than one table. So it's designed to hold a collection of tables. So you can put as many tables in there, and they just give them each a different name. By default, again, table 2, table 3, table 4. These things are searchable. So it's a collection class. So it has ability like array lists and hash tables. You can search them, you can sort them, you can reach in there and modify things. Just keep in mind you're disconnected from the database. So if you update, what you're really updating is the data set object. You are not changing the database until you reconnect. So what you really have is a data structure that you're working with locally, but it's basically a database. It has views, it has relations, it has constraints. Microsoft is trying to make this it's basically, as much as they can, an in-memory database. And so the example here is something you can do, for example, with SQL Server. You can batch up the SQL. So you can have not just one query, but a bunch of selects, and just send that as one command. So you don't have to actually do them one after another. You can batch up your SQL and then just do execute, or in this case, adapter.fill. And what it will do is fill the data set with all 4 tables. So basically, I'm sucking all the data out of the database, and I'm going to break and then put it into the data set, and then I'm going to close the connection, and then I have the whole database basically local to my client application. And I can bind this to a grid, and basically data grid, and see all 4 tables if I choose. So those are the kind of games you can play with data sets. They're a very powerful object. But just keep in mind, of course, that if it's a pretty big database and you suck out all the data, that's a pretty big data set you just built in memory. But, so it gives you that option. You just have to make sure it works for your situation. Okay, let's clean up that slide. What I will do is let's pause just for a second and look at a couple questions, and then I'll finish up with how to write to a database, and then we'll take the final questions at the end. Mark had a question. What about the DAAB, Data Access Application Block? I think I'm not going to talk about that today because I'm not really going to use any frameworks or tools, Mark. But I'm going to mention that at the end. Basically, as I've mentioned before, like with exception handling and GUI programming, Microsoft supplies application blocks, which provide a framework in which to do these things. And again, there's lots of wizards that will generate all this code for you. So I would encourage you to look at those. You just have to decide if they work for you or not. My goal today is to sort of show you how this stuff works, and then you can write it yourself or use wizards. But if you use wizards and things, you'll understand what that code is and the trade-offs maybe of why they're using a data set versus a data reader. Yeah, so some of these, was execute row removed? I think so, because I'm not sure, Patty, but I'm pretty sure it was removed because I don't remember seeing it. I think so. So someone's asking about execute row. I believe that's gone. How do you find the changes in records in a disconnected data model? Yeah, if you look at the data set object, you basically can filter it by the records that have been changed, and I forget the property or something. But you basically can walk through, or each record has a is modified field or property, and you can walk through the data set like I showed you how to iterate through it for each row. So each row has is modified property. And so what you do is iterate through the data set, looking at the is modified property of each row. If it's been modified, then you can work with it, or you'll know it's been modified if it's true or false, that property. Someone's asking about SQL injection attacks. Excellent, Mike. Not yet. Next couple slides. I'll talk about that in a second. Next couple slides. But no, to prevent yourself from SQL injection attacks and hacker attempts, there's something you need to do on top of just string.format. String.format really just builds the query. I'll show you what you need to do next to make sure you can sort of prevent those injection attacks. What's the difference between untyped and typed data sets? Can't do that today. Can you please reduce the fonts? Oh yeah, next time. Typed and untyped. I'll talk about in the coming weeks. If you don't need an updated data set, would you use a data reader instead of a data object? Okay. Okay. Someone had a question about, okay, so data sets work with data adapters. The other technique uses a data reader. So they're separate approaches. So data reader is the server-side connected way. Data adapter, data set is the disconnected way. So you use those separately. I'll just leave it at that. Data sets can be security risk. I'm not sure what you mean. Well, I mean, you're moving data across. It depends how you use them. I guess that depends on use. Anytime you move data across a network, it's a security risk, right? So you want to make sure that the network is secure, or it's within your firewall, or that you encrypt this data as it moves across. So you'll have to decide that on the. Yeah, you can sort these things. Okay, someone's asking about execute scalar versus execute non-query. What's the difference between, okay, this is the last question. Execute scalar is for reading, not for modifying. So execute scalar is for reading, not insert / update / delete. Okay, so that's it. Let's, how is concurrency handled in data sets? I don't think they're thread safe. So you have to basically I would assume, I haven't checked the docs on that, but I don't think data sets are thread safe. So if you have multi-threading going on, you'll have to worry about the threading issues, I believe, yourself. So think of a data set as just another data structure, like an array list or a hash table. Those things are not thread safe. So you will have to deal with that issue just like any other collection class, I believe. You have to create a synchronized version of it or use locks and unlocks like that. So I believe so, but that's the answer, but I'd have to check that. Multi-threading is a whole other animal, and hopefully we'll get to that near the end of the webcast series. Whoops! What is that? I'm not summarizing yet. Sorry. That's the slide I want. Okay, so we'll finish up in the next 10 minutes or so, and then we'll take questions after that. Okay, so let's look at writing or modifying a database. So everything we've done so far, reading. So let's look at modifying the database. So you really have two choices. What I want to do is quickly show you, or at least for sure, demo one of these ways. But again, it's connected versus disconnected. If you are connected, if you have an active connection to the database, and when in doubt, I would prefer this approach because you can deal with errors in real time. You're connected to the database. If it fails, you fix it right away. If you're disconnected, it's much harder to fix in general. So execute non-query is the method you call. Again, what you're going to do is build an SQL statement. So again, open, execute, close, in the minimum sense. Here, it's just a different method you call. So the SQL here is delete from customers where, and I'll flush that out in a second. And then basically, so once you have your SQL, you then create your command object, and really the only difference is you say command.execute. And then this executes, but it's a different method because we're not expecting anything back in terms of data. What we're going to get back is the number of rows that were modified. So in this case, if you're expecting to delete one record, I would also check to make sure one record actually was deleted. So I usually do this little sanity check when I'm done. I build the SQL. I kind of say, okay, I'm expecting to delete one customer here. But maybe the SQL is wrong, the database is wrong, or I deleted 2, or I deleted 0, or something's up. So I execute non-query, and then I check, and then I get back an integer, which is the number of rows modified. If it doesn't equal 1, I throw an exception saying, hey, something's wrong here because I expected to delete 1, and I certainly did not. Maybe it's 0, maybe it's 2. But something's up with the database if I didn't delete precisely one customer typically. But it depends on the scenario. But here you get back an integer because execute non-query is all about modifying. This is how you write to the database, either insert, update, or delete. So this is how you do it. The other ones are for reading. This is for modification. And the way to sort of think about this is the stuff at the bottom of your slide. What you want to do or think about this is what you're really doing is the client is just sending SQL to the server. And it's going to be executed on the server. The database will be changed. And then what comes back is an integer, the number of rows that were changed. Okay, so I'm going to run a little demo here. It'll take me a second to set it up because I commented it out. But before I run the demo, let's look at something first. And I'm doing this, there's different ways. The right way to delete a customer would be by their customer ID, because the customer ID is usually the primary key, and that would be unique. I'm going to just do this a little differently. I'm going to delete things by their name. Granted, this is not the best way to do it, but there's something I want to demonstrate here. And the key thing I want to demonstrate is how to properly build the queries, and also you want to protect yourself from SQL injection attacks, and also just the whole issue of delimiter characters in the values that are going in and out of the database. So what you want to look at the bottom of the screen before we write the code, but then you'll see the code on the next slide. I'll come back and reinforce this again. We're going to do a demo where we do a delete. Now it's probably hard to see, but let me see if I can point your eyes toward it. Look at when I build the SQL string, notice I'm putting quotes around the argument. So of course, if I delete someone by name, I am deleting them using text fields. And we know that in SQL, text fields must be delimited. So you have to include those delimiter characters when you build the SQL. So that's message number 1. When you build SQL on the fly, you've got to build it so it's correct, which means you need those delimiter characters around your text fields and your dates and things. So you want to put those single quotes in this case. I prefer to use single quotes for this, around the text field values. Okay, so that's issue 1, is you've got to include the delimiters because it has to be properly formatted SQL. So that's like, yeah, okay, no problem. Got to make sure it's SQL, so I put around single quotes around the first name and last name that I'm going to search for to find the customer to delete. Now, once you accept that, now you have to think about the case, and I do this on purpose. I have a friend named Kathy O'Dall. Notice, let me circle her in the list box. You can't really see it, but there's a quote in her name. Now, if you don't do anything about that, this SQL will fail when you try to build the SQL string with her name in it, because now you have a single quote and it has not been escaped. And so the SQL will not be properly formatted in the case of her name. So you must go through and properly escape the delimiter characters. So as soon as you start working with delimiter characters, you have to consider the case that the values that you're working with may contain that delimiter character, so you must replace those or escape them. So you'll notice what I'm doing in the code here is I'm going to do a replace. Replace every single quote with 2 in a row, and that's how you properly escape a delimiter character. Put 2 of them in a row. This is also how you prevent SQL injection attacks. Most, if not all, I hate to say all, but most injection attacks are based on the escaping mechanism. You put a single quote there and then basically inject SQL. And so what you do is if you do this technique, which is you do the escaping of delimiter characters, that injected SQL will not be interpreted. It will lead to an invalid SQL statement that will be rejected by the database engine. So this is one of the primary ways you prevent SQL injection attacks, is you must remember to escape single quotes, or basically any escape character, in SQL or any value typed in by the user. So let's pop over to the demo. Let's run this real fast, and then we'll finish up. Let's see, which demo? Sorry, let me think for a second. I want to do SQL Server version of this demo. And bear with me for a second while I fix the code that I commented out before. I forgot the code was originally in Access, and I had not intended to copy and paste it all. So let's find that code. Yeah, I'm sorry, the fonts are too big, but you know, I'm used to teaching in classrooms where things need my big fonts. So let me just real fast go through and fix this. Shouldn't take but a sec. We need to switch back over to the connection objects. Let me go ahead and show you what happens if you don't escape things. BC dot. So I'll go back to, I'll properly delimit things because it won't work unless we properly delimit. But I won't worry about the values. I won't actually go through the text values and escape things. We'll just take them in their raw form and we'll see what happens. And then we need a SQL dot command object. All right, and I think we are good to go. If it builds, it should fly. Okay, cool. Let's run this bad boy. We are talking to SQL Server. It'll bring up, yeah, it's open. Great. It's closed. Great. And now we have our database. We have SQL Server. So what I'm going to do is go in. Let's get rid of the bad guy, of course. So delete selected. What it's going to do is, again, the code we saw, it basically built an SQL query. You know what's really cool? I forgot this. Let me pop up a message box with that query so you can actually see it. It's very cool to see that. You can just, let's pop the query up and see what it looks like. Okay, so when I click on Jane Doe, we'll delete poor Jane Doe next, and I say delete selected. So here's here's the dynamic query that we built, Jane Doe. So you see her name embedded there properly with delimiter characters around those text fields, and then that gets executed by the server, execute non-query, and you see it's actually deleted, and you notice that bad guy's gone and now Jane Doe's gone from the GUI, but it's also gone from the database. Now for demo purposes, let's pick my friend Kathy. Let's delete her, and notice the SQL, and in particular focus your eyes on the end of that string. You'll see that it's delimited with an opening quote, the O, and then there's the closing quote for the delimiter. And now the SQL server doesn't know what to do with the rest of the SQL, because it was the text ended on that second quote. So it was not properly escaped, and therefore the SQL query here is going to blow up, halting due to our incorrect syntax. Right, so it blew up right on the doll part of her last name, and that's because I did not escape things. But this is also the idea behind SQL injection attacks. What hackers do is they basically know that you're building SQL, and so what they do is they purposely put single quotes into the input, and then they put SQL after that single quote because they, basically to get executed as you execute your normal SQL. So that's how they inject things. They put things through this quoting mechanism. They end your query and start a new one, basically. So now what I'm going to do is properly replace single with double. Let's pick Kathy's name, Kathy O'Dall. Let's delete her from the database. And now notice the end there now. Focus your eyes on the right. You'll see O'Dall, but it's O double quote, and that's single. So single quote Doll. Now I've properly escaped it. This goes through the SQL engine fine, and then the database engine unquotes it, of course. It sees 2 in a row and generates 1. So then she's properly found and removed from the database. So she's now been deleted from the database. Whoa. Good job, Joe. Nice code. Okay, don't know what that was, but let's make sure Kathy was deleted. So there she is. Not sure what that error was. Okay. So there's one way to modify the database. You know what? While I'm here, let's just do the other way, so we'll have the complete suite of demos today, and then we'll go back and finish up. So back in the data grid. So again, data sets are your other option here. So data sets are an option when you read things. Data sets are also an option when you write things, if you so choose. I'm not necessarily recommending this approach. I'm not sure having things disconnected for long periods of time and then trying to write it all back works in general, but it certainly works, you know, in certain situations. So what you'll see here is, you know, this is what we saw earlier. I'm reading in the data set and binding it to the data grid. Now notice the file menu has a save. So, but right now the connection to the database is closed, and by default the data grid is read-write. So I can actually add records here. So 1, 2, 3, 4. Joe Hummel. Let's see, his credit limit. Oh, he's got a lot of money to spend in his dreams. His balance is 0 because I haven't spent anything yet. And then today, what is today? 4 something. 25,205. And he notes he's having fun today. So what I did was I just added a record to the data set, which is local to this client application. I can also reach in here and change Jim Bag's name to Jimmy. And then as soon as I basically leave that record, that change has been also, probably that column, that change has also been recorded locally. 1, 2, 3, 5. Mary Beth Hummel. My wife doesn't get quite as much money to spend. She has no balance. And we add her. So basically, again, I'm making disconnected changes to the data set. Again, everything's local. Now, if you want, I can write all these changes back, the 2 new records and the change of Jim to Jimmy. Basically, what the save button does, the code is in the slides that we'll see in a second. When I hit the save, what I do is I'm going to reconnect to the database, and then take the dataset object. Instead of saying dataset.fill, I'll say dataset.update. And what you do is establish that you open the connection and say update, and it basically goes in reverse. The dataset object or the adapter object goes through, figures out what records have been modified because there's a property on each one, and then goes and basically does either, and it has SQL that it uses by default, or you can actually write your own SQL to do the updates. So what it will do is do an update and 2 inserts, because I changed 1 name and I did 2 new records. So it automatically goes through and will add those 3 records. Let's go ahead and save that. That worked without any errors, because it's very simple here. It's a single user scenario. Obviously, in a multi-user scenario, there could be lots of issues that could happen. But by default, it works very well as long as you basically know that the changes you're making can sort of guarantee that there are not going to be any issues. If the potential for conflicts are there, then that's the hard part. What do you do if there's a conflict? Because who knows when the conflict was generated, how many hours ago. So let me go ahead and halt this application. Let's just go back, just so. Let's just make sure. So I'm going to fire up the other way to look at things, just so you see it differently. And you'll notice that the name was changed, and there's Joe Hummel's here, and my wife's there. Her name's actually Laura. But Mary Beth and Joe are in the database now, and Jimmy's name was changed. So you can also do writing through the data set. Again, it's just a disconnected scenario, and you have to decide if that works for you. Okay, let's finish up because we went past my hour, which is usually an hour 15 minutes. But anyway, so building SQL queries, again, key to remember whether you're reading or writing from a database. When you build these queries, make sure you delimit things that need delimiting, and make sure you escape things, not only for correctness but also for security. So you want to make sure you escape those delimiters. Data sets, as I showed you, are another way to write to the database. You can execute the SQL or disconnect, make the changes in a disconnected way, and then the code here on the slide shows you how to, or at least one way to basically flush those updates back. So there's a command builder object that basically looks at the adapter, and the adapter has the command, which has the SQL. So it looks at the SQL that you use to read the data out, and then builds a set of action queries, insert, updates, and delete queries for writing things back. And then when you say adapter.update, it goes through the data set, looks for the records that have been modified, and then executes the appropriate SQL. If anything goes wrong, an exception is thrown, and then that's where you have to try to recover from conflicts What if you're inserting a record that was, what if you're updating a record that was deleted? What if someone else has already updated that record? Now you have update conflict, things like that. Or what if you insert a record and someone else insert a record with the same primary key? So lots of conflicts can happen because of the disconnected state. But again, it's another option of the 4. So session summary, let's finish up, then I'll hang out and take questions. I did everything by hand today, as I sort of said I would. No wizards. Lots and lots of tools out there, and lots of these are excellent tools. I just like people to understand what these tools are generating. So for example, in Visual Studio itself, it'll build a GUI form for you. Basically, just go into the project menu and add a data form to your project, and there's a wizard that will basically look at the database schema and build a form for displaying that data to the user. So lots of wizards out there. Take a peek at them, but at least you'll understand how they work. Otherwise, there's really just these 4 ways, that I talked about for accessing the data. You have connected or disconnected, execute scalar, execute reader, execute non-query, or a data set approach. And so really, you pick from those 4. These are some crude, very crude suggestions. If you're reading a single value, of course, execute scalar. If you're going to modify a database, I prefer the non-execute queries in real time. Because when I'm modifying a database, I want to know if it's going to fail so I can fix it right away. I don't want to do something and then 10 hours later update the database and find out that half the stuff I changed fails. So when in doubt, prefer real-time updates. So maybe you read the data as a data set, but when you do the updates, do them in real time. I think that's a safer approach when in general. Different ways to read the data. You can read it, execute the DB reader, server-side, client-side cursors. I think if you're reading a large number of records, it's expensive to build that data set and ship it down. It might make more sense in that case to keep the records on the server and request them as you process them. So if you had 1 million records, I don't think you want to build a data set with 1 million records in it. You probably want to execute reader, use a server-side cursor, and retrieve the records as you go. But if you want a convenient way to package up your data and pass it around, a data set's the way to go. You don't have to have any business objects. You just suck it into a data set, pass it around from your functions and methods, return them from methods. Very convenient, and as long as the data is not too large, I think it's a very valid way to go. Today, of course, just the tip of the iceberg, right? I mean, this is the best. In an hour, this is an hour and a half. This is what I do, and really just the tip of the iceberg, right? All the multi-threading issues, and as some other people pointed out, and I dismissed some of those questions because I just wasn't ready for them yet. There are differences between SQL Server, obviously, and Oracle and Access, and so how do you deal with vendor-specific things? And just a huge, interesting field. My goal is really just to show you the basics of how this works, so you understand the basics, and then based on your situation, you'll just have to run with it and then go from there. So, okay. That's it. Okay, so basically that's it for today. Let me just run through these last few slides. We'll come back in the future weeks, basically the month of May. We will flush out the rest of this and do some really nice, I think, elegant design and talk more about the trade-offs. So we'll do some nice interfaces and inheritance and talk about multi-tier stuff. I do have some additional resources here. Someone mentioned the data access application block. I encourage you to take a peek at that to help you sort of a framework to work with. I also listed here some introductory books that I like and some intermediate level books that dig deeper into ADO and database design, things like that. So based on where you're coming from, these are books I like, so I would point you in that direction. The website link is up here, lakeforest.edu/Hummel. So if you hit there, you'll see the slides and things, or print the PDF, and you can get these. So I think we have for those of you still hanging around, if you could, we're curious if the audio is getting better. So if you could, please give us some feedback, because those in charge think the audio is great, and our experience is that things are not so great audio-wise. So we'd like some stats to talk to our bosses. So cool. Thank you, everybody. Looks good. So if there's anyone else out there, cool. So I think actually it's better than last week. Last week was pretty ugly. And then I'm going to pop up the survey slide. So cool. Thanks for the survey results, and or the audio results, and then I'll pop the survey up. If you have a moment, we appreciate any feedback you can give us. I appreciate feedback on what's good, what's bad, and what I can fix and make it better next time. Cool. So thank you, everybody. If you can do the survey, I'm going to hang out, look at the questions in the queue for probably 10 or 15 minutes. And thank you for hanging out. Good luck with your database work. Hope you can come back in the coming weeks, and we will definitely hit this and do some really nice, elegant design work with this stuff. So cool. Thanks, everybody. I'm going to hang out, Miriam, and take questions. But otherwise, we are officially done.
Great. Thanks, Joe. So you're just typing the answers in?
No, actually, I'm going to voice them too.
Okay, great. So we'll just hang out and record your voice while you're answering questions as well.
Cool. Thanks. Okay. So Peter has a mention here. I'll post it to all. So what Peter's mentioning is that there's, for example, something. There's additional layers or abstractions of software. There's a lot of tools out there and a lot of good code that builds on top of ADO.NET. And I would strongly encourage you to look at these things because, as you sort of saw today, a lot of this code is redundant programming. I'll show you some elegant ways over the next few weeks. Other people have done some really elegant things, and Peter is mentioning something that you might want to look at. So I'm just going to zip through the questions. Okay, so I'm looking. Sorry, looking at the question. David had a question. Aren't bind variables a better way? Not sure what you mean. Sorry, probably didn't need to read that one. Oh, cool. Okay, I'm just going through the questions. Why not use parameterized queries? Yeah, so Travis has an observation. Why not use parameterized queries rather than string.format? Again, there's lots of different ways to do things. For me, as pedagogically as a teacher, the easiest way is string.format, I have found, because the most common way people build strings is with string.format, but usually by concatenating the pieces together. So string.format to me is a better way to do what people typically tend to do, which is concatenate strings. Yes, you can also use parameterized queries. You can, and that's a common way of, I've seen, typically when you have stored procedures to, build the string that way, especially when the parameters are in and out parameters. So I think it's just another way of doing things. Oh, okay. So yeah, Mark. Okay, so Mark had a question about when I was doing the insert or the delete. So he's asking about after you escape the single quotes, must you address them reading the data back out? No. So the issue is the escaping or changing the single quote to the double quote is merely to get through the database engine, so that the SQL is valid format. It does not change anything in the database. So the data goes into the database with just one quote. So like if you were to insert Kathy O'Dall's name, you would definitely escape it and insert her name with two quotes in there. But then the database engine strips one out and inserts it as O'Dall with one quote. So the escaping mechanism is to properly interact with the database execution engine. You don't need to, it doesn't have two quotes in her name when she's in the database, and you don't have to then, when you read it back out, strip one of the quotes out. It's really just to get through the engine to properly parse or properly build the SQL string. Someone's asking about transactions. That's going to in coming weeks. What's the best practice to store connection strings? Yeah, well, the obvious one is config files. So I mean, people have issues with config files. I mean, for example, they can be edited. They're readable by the user. So then there's, I'm trying to remember. There's a white paper about that. Email me for a link to a white paper. But there's lots of schemes that people have come up with for dealing with connection strings. But I guess the first answer is for in general, you generally try not to embed the connection string in the code, so that what we're going to do in the future coming weeks is move it out into a config file. And then if you're worried about security, what we'll do is instead of using a config file, we'll suggest some alternative approaches. So I'll talk about that in the coming weeks, but if you want an answer now, email me, and I can talk about things other than config files. But you definitely don't want to embed those connection strings into the code if you can avoid it. So config files are an easy way that we'll certainly talk about. How do you ensure the integrity of the database before executing the update command? Good question, but basically that through, I mean, the integrity of the database is, there's no automatic mechanism, right? Because the integrity of the database is based on how you build it, design it, and then manipulate it in real time. So you have to basically make sure that, as you make modifications to the database, you don't break any of the integrity rules. Now, some of those can be enforced by the database engine itself, right? But basically, when you insert a record, you've got to make sure that when you insert it, you don't have a duplicate primary key, otherwise it'll throw an exception. So at least the engine will throw an exception in many common cases. But in general, integrity is enforced by you and your programming approach. There is no automatic way of the tools can maintain integrity in all cases. That's really up to you and writing the application and logically correctly, unfortunately. But, of course, with database design, there are things you can do, constraints and things in the database design that will help ensure integrity over the long term. Okay, where can I find the schedule? Where can I find the schedule of future classes? On my website, www.forest.edu/tilde/Hummel/web. Sorry, I'm still reading through questions. Wow, cool. So someone has mentioned this. I didn't know this. People use execute scalar to do inserts. I didn't know you can do that. Not sure. Not sure that's a best practice. But okay. But someone's pointing out that you can do execute scalar basically to do an insert. But okay. I don't ever do that. But if that works for you. Oh, Lake Forest is currently. Oh, my website's down. Oh, okay. Sorry. I'm not sure why lakeforest.edu is broken, but my college is not the wealthiest in the world. Eventually, I'll move that off to my own site. I'm not sure about that. Sorry, Pradeep, I'm not sure about that one. Is the provider the same for MSD? Oh, yeah, good. Thanks, Rich. So when you work with SQL Server, yeah, I forgot to mention that. MSDE, the Microsoft Desktop Edition, right? Developer Edition. Yes, think of MSDE as SQL Server, basically. So most developers work with MSDE, the developer edition of SQL Server, and then you just deploy it to your deployment with a real SQL Server version. But yeah, think of MSDE as just your local edition of SQL Server. The same connection strings apply. That's the good news. Is it's basically SQL Server just for you and not licensed for general use. Just to verify, data reader objects create read-only. No. Oops, sorry. No. Data reader is for connected reading of records. Data adapter is for reading, writing data sets. So there's just some confusion about data. The data reader object is for reading in a connected way. So server-side cursor, read, the records come to you. Data adapter is for data sets, reading and writing. Ah, cool. So someone's asked about the schedule about the webcast. I'll post that to everybody. Ah, cool. Thanks, Pradeep. When you want to connect to SQL Server, use the native provider. Use SQL connection, which really means system.data.sql client namespace. When you talk to SQL Server, you want to use the native provider, which is the SQL client classes. And then Oracle used the native one. And then only use ODBC and OLADB drivers for cases when you have to, because they're non-native, they're slower. You have to go outside .NET to execute them. So yeah, thanks, Pradeep. Okay, so someone just came back, but I just looked up in the .NET. Data reader will fill a data set with read-only data. Okay, I didn't know that. Okay. Anyway, so someone's saying you can use a data reader to fill a data set. Okay. But basically, okay, I have to see, I didn't know that. Okay. So sure. But not how I use it, sorry. I mean, the thing about, and that's, I mean, it's a good point. What you find with this database technology is, and the databases in general, there are thousands of ways to do everything. So today I showed you the 4 ways, the typical 4 ways of doing things. And there's always, and people are rightly pointing out, thank you, there are other ways to do things. And you certainly want to look at those other ways of doing things, see if they work for you, and run with them. So for example, someone uses execute scalar not to read things, but to modify the database. I have never done that. I don't know if there's any trade-offs. I would personally not use it because I thought execute scalar is for reading things. And so the database engine may be making assumptions about locking that you don't know about, so that writing to the database works, but not in general. It works in their particular situation, but in a general scenario with more users, it may not work because the locking's not right. I don't know, but certainly look at other ways to do things, and I encourage you to point them out to me and others, but read them and then make sure that that's actually a valid way to do it. So when I use data sets, I use data adapter. That's the only way I fill it because that's the standard way to do it. Okay, one last question, David. Yeah, sorry, I haven't looked at the next version of .NET yet. So the question was, what's going on with 2.05, the next version, .NET 2.0? To be honest, I haven't had time to look at the database side of things. I would look for some blogs that might cover that. So I don't know if there's any major changes. Lots of small improvements. Not sure about major changes. Sorry. My guess is, my understanding is that all the stuff we talked about today is still valid, but they're increasing support, for example, for XML and things like that for sure. But other than that, I'm not sure. One of the big things coming in 2.05 and .NET is that you can embed .NET code into SQL Server, right? So you can write stored procedures in C# and VB and not have to use, TSQL and things like that. So. Okay, cool. Looks like the questions are gone. I think I've overshot my time anyway. We are done. Thank you very much for the feedback and the questions, and hopefully see you back in 2 weeks. Take care, everybody.
Thank you very much, Joe, for presenting today and answering all those questions. Thank you, everyone, for attending. Ladies and gentlemen, this concludes today's MSDN webcast. At this point, please disconnect from the audio portion of this conference. Thank you.